Hi everyone, this is Venki here. I'm the product lead for Greenplum, and I have with me Chris Hayash, the engineering manager for query processing for Greenplum. Today we wanted to share with you the features that we released in our recent release of Greenplum 7.6. We're just going to do a brief highlight and what are the upcoming features that are coming in association with these features. All right. So we're doing a tag team between me and Chris. So Chris is going to take a couple of features and he's going to dig deep, and then I'm going to conclude with some of the other features that he hasn't covered. In Greenplum, what we are looking at is a massively parallel data lakehouse with our Greenplum offering and as well as the data lake offering, the Towns of Data Lake. And we have five main dimensions in which we are innovating in every release. We usually release a version of Greenplum every 3 to 4 months. These five dimensions are we improve how we store or replicate data inside Greenplum, how we make queries faster, how we ingest or cache data in an efficient way, how we improve analytical utilities that come along with Greenplum Data Lake, and lastly, how we manage and monitor our Greenplum clusters. And all of these are very important for the BI applications, the data science, and analytical workloads that are the end users of the data that is coming out or monitoring that they have to do on top of Greenplum. So in today's session, we're going to cover only one aspect of these five dimensions, that is querying, right? And hence, that's why we have Chris, who is the engineering manager for query processing. So the first thing I think Chris is going to jump into is the support of lateral joins with Orca. Take it away, Chris.
Thanks, Vicky. So in 7.6, we've released a lot of really cool features in Orca, and one of the big major ones is support for lateral joins. So this is a new addition to support in Orca. Previously, when you tried to run a lateral join, Orca would fall back to the Postgres-based planner. And now, for most classes of queries that support lateral joins, Orca will now process those queries and accelerate your workload. So what are lateral joins? Lateral joins are per row subqueries, and they're mainly used in these top end per group patterns and to basically execute certain like results at certain types of queries on a per row basis. So when you're trying to execute a query that references an outer record and you want to execute that many, many times, you'll typically use the lateral syntax. So some common examples may be finding each employee's highest rated skill, a user's most recent login device, or the top end selling products for a store, or basically like trying to get some aggregate or some subquery that needs to execute on every single outer reference. Next slide. So kind of adding on to that, here's a more concrete example. So let's first look at we can look at the one on the left where you have a outer table customers, and you have a subquery here, this select o.oid order date from orders. And the predicate here is where customer ID, the order customer ID is equal to the customers, the outer table here. So this outer reference is, you basically use the syntax lateral here. And for every single customer, you're running this subquery and you're trying to get the top orders, the top 3 orders from that, basically using that join. And while you could do this using window functions, the syntax is much more complex, and it doesn't let the optimizer actually do some of the optimizations that it can do, because one, you're using a CTE, which is a common optimization barrier, and two, with window functions, just as you add more complexity, it tends to add more optimization barriers and limit the optimizer from being able to do some of the cool optimizations.
So I think, Chris, what are you telling me that when you add, for me, just as while I've been working with SQL for a long time, intuitively looking at lateral syntax, it's much easier. I can see customers easily building on top of this, right? Top three to with different filters, different functions. So it seems very intuitive. But when I see the row number, it seems like it's not so straightforward to see what a row number is. Is the row number for the table after the predicate, before the predicate? It seems a little convoluted. And on top of that, I think what you're trying to tell me, are you saying that if I add a row number, if I add aggregates and stuff, it becomes a hurdle for me to push down predicates, push down things? Is that what you're saying?
Yes, yes, Vangi. So when you add CTEs and in addition to it, window functions, every single one of these added complexities becomes another level that the optimizer needs to handle. And in some cases, it takes shortcuts to not handle those cases. So when you use something like lateral, it is a simpler syntax. It is something that we can more natively build up and push things through that will let you push down more predicates and just do general
Yeah.
optimizations, whether that's eliminating unnecessary joins and other things that basically the optimizer can do.
So, for example, if I said where if customer ID, even though it's a very naive, simplistic way, if only the odd number of customers,
Mhm.
right? If I had that function on the outer side of the queries, like from here, then that could be easily pushed inside to the lateral. Is that what you're telling me, for
Yes, yes.
example?
Yeah.
Okay, cool. All right, this is really cool for people who don't know. Thanks, Chris, for digging into this.
Uh, so this is another motivating example that basically just shows you what are other ways that you can use lateral joins. So it lets you treat each element of an array as if it was part of a separate table. So if you kind of wanted to build up a table, so in this case, you're trying to nest a large array and treat that as a table, you can basically use that using lateral joins. Whereas previously, you most likely would have to hack something together using subqueries or even temp tables. Uh, and this is a more concrete example. And this kind of this does use postgis functions, which is another feature of Greenplum. So here you can actually get the nearest stores using a k nearest neighbor query. So you could use the stdistance function and get the distance between or of the three nearest stores for a particular the three nearest stores for each customer. Uh,
Okay.
so
I
yeah,
can see that uh, before making it into a row number, that itself is adding the complexity rather than the complexity coming from the business logic which you are trying to do. The row number adds another layers that makes it more complicated. These are really good examples. Thanks, Chris.
so now we want to go over some of the disadvantages of lateral joins. So lateral joins, the syntax is good. And even if you were using window functions or anything else, you would get these same disadvantages. But it's good to be aware of this from the query writing perspective. And it may seem obvious that for every time you're triggering or executing on the outer reference or the outer row, it's going to trigger a fresh execution of the lateral subquery. Uh, and there are some limited join optimization strategies that you can do with this. It's always a nested loop join, for example, uh, and it's not commutative as only the inner relation is allowed to be lateral. So it does have to execute the inner subquery every single time. Uh, and there are some optimizations that we can do here. If we can prove that, for example, it only needs to be executed a finite number of times, or it only needs to be, or we can possibly make it into a hash join, but we can't always prove that that's the case. And if we can't prove it, then we can't do it. Uh,
Okay.
so the other thing is there is some black box costing here. So if you use UDFs and TDFs, there we can't necessarily do costing as accurately as we would like.
So if you had like basically if you do unnest, right? Unnest, for example,
Mhm.
one of the columns could have 100 rows, another column could have 1,000 rows in an array, right? You don't know because when you're unnesting, you don't know exactly how many rows you're going to get because each row, the array could be having arbitrary length, right? Is that what you're trying to say? So you
Exactly.
don't know exactly what you're going to get because it's a table valued function or a user defined function. Okay, got it.
So some best practices that we would recommend. So use lateral where it shines. So nearest neighbor queries where the semantics are very clean and intuitive. Keep your subqueries simple. Remember that these are being executed multiple times for every single outer reference in the table. Uh, so you don't want these to be ridiculous functions that are executing on complex views unless that's actually necessary. But just be aware that this can increase the execution time if we just make this, or if you make this super, super complex. Uh,
Got it.
and then in the future, we'll support index lateral joins as well. But
Mhm.
currently, we don't support this, and the repeated execution can quickly become a performance bottleneck. And by default, this feature is disabled, as there are still some improvements that we're working on.
And
But we,
also because
yeah,
this is a
the,
this like we want basically what you're telling me is we have to get all of the performance improvements in before we turn it on by default.
correct. Yes, we do understand that this is a stable version. We don't want to introduce any surprises. So this is a feature that you can enable you can easily enable by turning on the Guck optimizer enable lateral, and this can be done at the database level, at the query level, whichever you're most comfortable with. But by default, it is off. And for future work, we're looking at enabling indexed lateral nested loop joins. So this will leverage index scans and improve query performance, uh, converting lateral joins to regular joins when possible, supporting more join order optimization for lateral joins, and supporting some other use cases like left lateral joins, uh, lateral function calls and lateral values, and then supporting lateral joins with foreign tables.
Cool.
So another feature that we added in this release is previously when you would create a table and not analyze it, Orca would assume that there was one row there. And this usually was not accurate. Uh, in many cases, this would cause things like group aggregates and nested loop joins to occur. And the common use case we would see here is, say you have a large function that creates temporary tables and then drops those temporary tables afterwards. And you either forget to analyze that table or you just aren't aware that you need to analyze that table. And you would get a poor performing plan. So Orca now has a default value for these tables, and we assume that they're going to have around 1,000 rows. And this is a configurable value, but it will basically create a higher bound or an upper bound uh, for what a reasonable number of rows is that will at least get things like hash joins and hash tags. And in most cases, in the vast, vast majority of cases, get much, much better plans when you don't analyze your tables. So in cases where you are already analyzing your tables, this has no effect. But in cases where either you forget to or you didn't, it will most likely significantly improve those plans.
Yep.
Uh, so yeah, we want to say that this Guck is and this feature is a fallback. It's not a replacement for analyze. You still need to analyze your tables to get good statistics. It only affects tables that have not been analyzed and doesn't take into account data size or data distribution. You need to analyze in order to take into account those type of statistics.
Thank you, Chris. So the next feature which I want to talk about, um, this is in many scenarios, customers expand their data because their data is constantly growing. They add new segments, new cluster nodes, and with multiple segments on that cluster nodes. And because there are petabytes of data, so you can't expand and rebalance the data all at the same time. So slowly, whenever they get the time window during downtime, like a couple of hours in the evening, or a time when there is not that much business activity going on, they start slowly rebalancing the tables. So you start off with like all the tables being on all segments to, hey, only two tables are distributed in a very uniform way. The other two are distributed only on a subset of segments. The issue, what this triggers prior to this release, is that Orca used to not able was not identifying how to handle joining between tables which are distributed on a subset of tables with tables that are distributed across all segments. So it'll fall back to the planner. And we have had many regressions where customers have said, hey, my query was running like in a couple of seconds and now it takes us 10, 15 minutes and I'm not meeting my SLA. And when we dig into it is because it Orca falls back to Planner, and Planner is more transactional based rather than analytical based. So the Planner generates a plan which does not have good partition elimination, is unable to handle correlated queries, is suboptimal for with classes. So the performance really takes a hit. And expansion itself is quite challenging of a process because you have huge amount of data and you have to balance all of your tables, and it becomes unreasonable that when you expand, you should also balance it immediately, right? And that's one of the pain points we wanted to solve in this. So before we go into that, let's look at where tables are uniformly distributed, right? Say customers and orders, and uh, they are distributed by order key or customer ID. And so now what we have is when you have a plan that is generated, because customer ID is the way it's distributed both the tables, we know that the joins are co-located and you can generate a plan that is exploiting the parallel nature of Greenplum, right? However, when it's non-correlated, say for example, orders is still only two segments rather than all segments in the database. Orca now will say, hey, this is in two segments. Our customers distributed on all segments. Now, can I introduce a redistribute motion so make sure that the right customer orders are in the same segment so that I can have parallel execution of the joins? This way, the joins are co-located and you still exploit all of the performance improvements that Orca brings to the table for all of the analytical queries, right? So basically, the takeaway is you expand freely, meaning you don't have restrictions or balancing it immediately, and you can stage how you balance all of your tables. Just as an intuition, this is a toy example. It's just a 1 GB on two segments. And what we've seen is when we went from um, two segments to our unbalanced segments, then what we see is we get a huge amount of performance improvement. It used to take in 7.5 the 38 seconds, and now the whole query runs in 190 milliseconds. So you can just see even for this small segment of two segments, and I add a third segment, it takes such a big impact of not falling back to planner and doing all of the performance test. And TPCDS query 6 is a reasonably um, um, straightforward query with multiple tables and joins. So if you imagine you have petabytes of data, a complex query, the impact will be much larger. All right. Um, so the key benefits of this feature is we don't no longer fall back to planner. We get all of the benefits of partition elimination, correlation, handling, and you can turn it. It is currently turned on by default because it's a completely feature complete feature. Unlike lateral join, because we are constantly iterating on adding more features to it. So it's already on by default, where you just say optimize enable subset segment distribution. That means data is distributed only a subset of segments. And so then you can have the expansion with less of a worry of plan degradation. And the last topic which I wanted to cover with everyone is the Postgres REST API. Postgres API. It's a kind of a tongue twister. So Postgres is a fully RESTful API for any Postgres like database like Greenplum. Postgres REST converts any incoming REST requests into SQL, so it can view objects, we can view tables, you can query on functions, and it also all the permission handling and all of those security aspects are handled by the database, so you don't have to worry about it. And it handles multiple media type handlers, so you can visualize what you get from the Postgres REST on your different applications. So this is a very frequently asked of how to have a REST API connection to Greenplum. So we have extended the Postgres API for Postgres to now support Greenplum database. Um, that's a brief summary of the query optimization features that we have. This is a three-part series where we cover the 7.6 release, which was released in the end of October, where we have query performance improvements, storage enhancements, as well as cluster monitoring and management enhancement. Thank you so much, Chris, for joining me on this session, and I will see you folks in the next video. Thank you so
Thank you.
much.
Thanks, folks.